Hello everyone. Today we're going to talk about something called a binomial distribution. Okay, I'm just going to write up here. These are your notes. Okay, and this is still in chapter 5 is where we're working. Okay, so a binomial distribution, binomial, has only two outcomes. Okay, so if I ask you how many outcomes is in a binomial distribution, you're going to say 2. Okay, now there is what could we think about? Things that have two outcomes, like a coin toss or a true-false question. Oh, I know one. How about a multiple choice question? I always like to sneak this one in with 5 choices. Okay, now you're all sitting there thinking, come on now, you just said 2 outcomes. Okay, multiple choice with 5 choices has 5 outcomes. Okay, well, think about it a second. Wait for it. Maybe it just occurred to you. You could see that as being right versus wrong, or correct, incorrect. 2 outcomes. So we can make it reduce to 2 outcomes. In fact, part of the definition says each trial can have 2 outcomes or outcomes that can be reduced to 2 outcomes, and that would be the case in the multiple choice example. Okay, so let's keep going here. When we do something binomial, we have to have a fixed number of trials. The trials must be independent of each other. Okay, so the fact that something happens on, let's say, tossing a coin and it comes up heads, that doesn't affect the chance that you toss the coin a second time and it comes up tails. Okay, and the probability of a success has to remain the same for each trial, remains the same. So in other words, if I'm flipping a coin, I flip it once and I'm not like going to bend it in half. It's so that it affects the outcome on the second toss. Okay, that's sort of an idea. Okay, so then down here I have all kinds of notation about binomial things, like the probability of a success is P of S, probability of failure. We have a p-value, which is probability of success. This Q, the capitals lot got me. It's usually a lowercase q, and this is really lowercase p. But Q is probability of failure, okay? And we know that P plus Q has to add up to be 1, a success and a failure. Like tossing a coin, say toss coin, chance of tails. Okay, you tell me that's 0.5. So if I want to count the tails, tails is 0.5, that would be a P. If I want to then say heads, in our little example would be a failure, that's also 0.5, that's your Q value. So 0.5 and 0.5 makes 1. All right, so then to calculate binomial probabilities, we have this great big formula, okay? I can also reduce that down into something that looks like a combination. It looks like P to the X, Q to the N minus X, okay, which is the same thing written differently. Okay, or a third way that we can deal with this is something on your calculator that we can access by doing second, and you hit the button that says vars. Okay, and above it, it says distribution, or DISTR for distribution. And I want you to scroll down until you find there's 2 choices. One that says binom PDF, and the other one says binom CDF. Okay, and then the keystrokes that go with it are an N, a P, and then an X. N, P, X. Okay, if you're on a TI-84, I think it'll say number of trials. Yeah, we're going to have to look that up, and I'll have to add that to a future video because it is a menu. So it may even say the N, the P, and the X. This way, it's like vertically, you get a little menu instead of having to go straight across like some calculators. Okay, anyway, the difference between the P and the C, okay? The PDF, this one right here, okay, is going to be for one single probability. So if I ask you for something like X is exactly 2 in the middle of a problem, you're going to pick a PDF, okay? If it comes up different, some sort of an inequality, a greater than or a less than, then we're going to have to deal with the CDF, okay? So CDF is a adder, like a cumulative situation. So it will add up the probabilities from X equals 0 up to and including X equal whatever you put in that last value, okay? So it's accumulating probabilities. Okay, all right, so let's go down here and take a look at a couple examples. A coin is tossed 3 times. Find the probability of getting exactly 2 heads. Okay, so to fill in a binomial PDF or CDF, you need 3 things. We need to know N, we need to know P, and we need to know what the X value is. All right, so in this case, tossing 3 times, that's N. Okay, P is going to be the probability of getting heads. Chance of heads is 0.5. Okay, and then down at the end of the question where it says exactly 2, all right, that's implying X equals 2. All right, so since it's an equal, we want to do a PDF. Okay, so equals is always PDF. All right, so to set it up, we're going to get in your calculator and do second. In fact, I could probably write this right here. Because it says exactly, use PDF. Okay, so we'll do second vars, go down to binomial, PDF. All right, the number of trials is 3. That's how many times you do something. All right, probability of success is 0.5, and then your X value is a 2. All right, and if you push that in there, you should get an answer of 0.375. Okay, so that's the probability of getting exactly 2 heads when you toss 3 times. All right, let's try another one. A student randomly guesses at 5 multiple choice questions. Find the probability that the student gets exactly 3 correct. Probability exactly 3 correct. Each question has 5 choices, and we also, there are a lot of 5s in this one. 5 multiple choice questions. Okay, so let's see what we know. Okay, we need to know N. Okay, so how many questions are there on our test? Well, that would be 5. That's right here. That's your N. Okay, then P, well, each question has 5 choices. So to me, again, I mentioned at the top, right versus wrong. Okay, well, how many are going to be right? 1 out of 5. Okay, so that means your P over here is 1 out of 5. And just for fun, what would Q be if that's the case? If P is 1 over 5, okay, you're right, 4 out of 5. Okay, and it's fine. If you want to say this is 0.2 and 0.8, no problem. All right, then X is going to be exactly 3. All right, so again, it says exactly. So that indicates for you to do a PDF. So we'll pull up second vars, binomial, PDF. N is 5, P is 0.2, X is 3. Okay, if you press enter, you should get the probability is 0.051. Okay, and that's the value you're after. Okay, last one for this practice. So we have a survey found that 30% of teenagers receive their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that at least 3 will have a part-time job. Okay, so this one's going to feel a little bit different because of this at least. Okay, so in this case, our x has to be greater than or equal to 3. That's the idea of at least. Okay, p-value is hidden up here. 30% of teenagers, that's going to give us our p, so 0.3. Okay, and then how many teenagers are we talking to? Well, that would be 5, so that would be your n. I got you a little out of order there. All right, now, this is going to feel different because we want, for any x, if I think of it as a number line, 0, 1, 2, 3, 4, 5, all the way to infinity, however many kids, whatever. We're going this direction. Greater than or equal to 3. All right, so greater than or equal to 3 is like this. Okay, what we don't want are the probabilities for 0, 1, and 2. Okay, so what we end up doing, knowing that the sum of the probabilities in a sample space are going to be 1, we're going to say 1 minus the probability. A couple ways I can say this. 1 minus the probability of x equals 0, x equals 1, x equals 2. So to do that on the calculator, like to get rid of these guys down here and just keep, I should have stopped this right here at 5 because our n's 5. And to keep the sum this way, we want this one, we would say 1 minus binom CDF 5.3 and 2. So we're saying 1 minus the sum of these probabilities. Will give us the sum on the right over here. So if you key that in the calculator, you get 0.163, and that's your final answer. Okay, we may have to talk about that one just a little bit more in a future video. Okay, as far as being able to figure out if you do 1 minus or what you have to do with that CDF. Okay, but in general, there you go. That's a nice intro to what we're going to talk about in this last section with binomial distributions. All right, be talking to you soon.